Hernandez.
Gladly, please. I appreciate so much. So you can remind me or another student, I appreciate so much. Extra credit for you, right?
Thank you.
Okay, Gladly. Okay, look. Suppose this example. But let me change a little bit too much. Okay. Erase. Now, the example is 14 x to the second power minus 11 x minus 15 equal to 0. Okay, quadratic equation already expressed in standard form. A is 14, B is negative 11, and C is negative 15. But unfortunately, I need to solve it using the complete square. Okay, it's a little bit weird, but okay, but it's important because in the test, one question is mandatory doing that way. And you need to know that. Remember, when A is not 1, get 14 in that case. It's A is 14. B is negative 11, and C is negative 15. But in this case, when the A is no 1, it's 14, whatever, you factor out this 14. And we have x squared without, so the action, so what the goal of this action is, when you factor out 14, now coefficient is here, invisible 1. Entonces now we are applying similar procedure that we are doing before. Now we have now negative 11 over 14. This is the confusing part. I understand that the last time the student don't understand very well this. Guy, this expression is equivalent 100% with this expression. Because when you, again, apply distributive property, you multiply 14 times 1 invisible and 14 times 11 over 14. Okay, of course, the 14 is canceled and stay 11. Do you see it or not?
Yes.
Yes.
But I include new guy because it's the magic number that allow me complete the square. In the right hand side, well, it's easy. I always moving 15 to the other side, in this case positive 15, plus another box. Okay, this box help me to keep the equilibrium of the equation. Okay, not necessary. This box is the same number of this, not necessary. In this case, no. When the coefficient is 1, yes, it's exactly the same, but when there's 1, no. And remember the magic formula, b over 2 squared. Okay, in our specific example, b is 11 over 14 divided by 2 squared. This is easy. 11 over 14 divided by 2 is exactly the same multiplied by 1/2. Because 2 is a whole number, you know, it's 2 over 1. When you flip it, 2 over 1 like a 1/2, you are doing the division. So it's 11 over 28. Now it's square. Because this is the formula. This is the formula. Entonces it's 11 squared over 28 squared. Don't be scared for the number because you put it in the calculator. It's 121 over 784. I put this magic number here. 1, 2, 1 over 784. And when I do this action, I am sure 100%. Okay, this trinomial is perfect square trinomial, and the factorization is two identical twin brother factors. That is the reason I condense it in only one to be ready to apply square root method. Okay. So far, everyone follow me? I want to explain the second box.
Yes.
Good. Yes. Let me explain the second box. In the second box, you put a number, okay, give me the result of the multiplication 121 over 784. Okay, the number that you put inside the parenthesis multiplication by 14. Because remember, when you apply distributive property, this 14 somehow multiply this. Okay? Entonces I put in the calculator one more time, and the answer is 121 divided by 56. Yeah, I put it here. 121 over 56. Cool? That was the complicated part. The rest is pretty easy. Well, you combine this guy together, you find the least common denominator, okay, 56. 56 times 15 plus 121, the answer is 961. Okay, ready. Now, let me copy my equation. So far is 14, x squared minus 11 over 14, x plus 121 over 784 is equal 961 divided by 56. What is the next? What is the next step? Well, the next step is divide everything by 14 because I want to eliminate this. You can do it like that. Divided by 14 here and divided by 14 here. It's exactly the same multiplication by 14 in the denominator, no? So it's x squared, 14 divided by 14 is 1, minus 11 over 14x, plus 121 over 784, and here is 961 divided by 784 again. Under factorization, this trinomial, always the technique of the completed square is to guarantee that this trinomial's perfect square is only one binomial square, duplicate, and the square root of this guy is x, and the square root of this guy I did before, remember, is 11 over 28. And this sign is minus because this sign is negative. I don't care this sign because this sign is always positive. Because you're adding the magic number, you never subtraction. So this don't, depending on the problem, is plus or minus. Now ready to apply square root method. Apply square root here and square root here. And so obvious que square root and second power cancel out each other. Entonces x minus 11 over 28 is equal, don't forget like plus or minus, and you compute square root 961 divided by square root 784. And the answer is 31 over 28. So 31 over 28. Now, finally, I solve for x. I move negative 11 over 28 to the right-hand side, like a positive, and we have 11 over 28 plus and minus 31 over 28. And you separate into pieces, 11 over 28 plus 31 over 28 and 11 over 28 minus 31 over 28. This is minus. Okay, I put together, this is 42 over 28, and when you reduce the lowest term, this fraction is 3/2. Okay, here is 11 minus 31 is minus 20 over 28. Again, reduce the lowest term divided by 4, I guess so, it's minus 5 over 7. Boom, final answer. Two solutions. Solution set for this equation using completed square. Wow, too long and confusing. I know, I understand. Now we create a shortcut to do fast. Is solution set is 3/2 and negative 5 over 7. Either way, the order is not important. Do you follow me? Everything is clear or confusing?
Yes.
But to avoid this too long process, maybe complicated number, I propose you one idea. Let's do it exactly the same, but using literal equation. What means literal equation? Literal equation means that we start at the beginning using ABC. So we start a squared plus bx plus c equals 0. A, B, and C is letter, variable. Non-variable, but I don't know. It's unknown value. And we apply exactly the same technique. What should I do? Well, you factor out A outside. And we have here B over A. Yes, X. Plus something. Complete square, guys. Equal minus C, because the C always go to the right hand side plus another box. So the formula is B over 2 square. Pero B over 2 en our specific example is no B, es B over A. Actually is B over 2A, because you divide by 2, this 2 and this 2. And B actually is no B, it's B over A in our example, no? A square. Okay, by the way, this is B squared over 4A squared. I copy here B squared over 4A squared. And now ready to complete the square. And the right hand side, well, you multiply by A. So it's B squared over 4A squared times A. This A is that A. Actually, is at least one A is cancelled out. And it's B squared over 4A squared. You copy here, B squared over 4A. Everyone follow me so far? Confusing or no? We are doing well or no? Tell me. Answer me. Hey, what happened? What's going on?
An example using this method.
You don't hear very well, mister?
Can we see an example with this method?
What do you say? Repeat, please.
Can we see an example with this method?
Absolutely. I always, my goal is you explain the theoretical part, and after you put 1, 2, 3, 4, 5, 6, 7 examples. 1,000 examples. Don't worry, for example, okay, in your moment, but step by step, no?
Yeah.
Okay? Okay. Now, I don't finish. This is the most important part now. Well, let me manipulate here. The right-hand side. You find the least common denominator, but in this case, literal equation to say es obvio que the least common denominator for A. Entonces we have minus 4AC plus B squared. I want to write more elegant in this way. B squared minus 4AC divided by 4A. Cool? Now, I know very, very, very well que this trinomial is perfect square. Entonces A x plus B over 2A squared. We're going from B over 2A. It's a square root this guy. So square root B squared over 4A squared is obvious que es B over 2A, no? Because square root B squared is B, square root 4 is 2, and square root A is A. In the right hand side, we have plus or minus, well, no, not yet. When you apply square root, yes, plus or minus. Is B squared minus 4AC divided by 4A. What should I do now? Exactly the same doing before. Divided by A. Divided by A. Divided by A. A squared divided by A. Divided by A, exactly the same multiplication in the denominator. So far we have x plus B over 2A squared is equal B squared minus 4AC divided by 4A squared. Now finally square root both sides. This is a square root method. Okay, now I know very well that square root and its second power cancel each other. Plus x plus B over 2A is equal now plus or minus square root B squared minus 4AC divided by square root 4a squared que es 2a. Wow, amazing. Finally, solve for x. I move to the left, to the right, minus b over 2a, plus or minus square root b squared minus 4ac divided by 2a. And not necessarily write like that. So you have the same denominator, que es 2a, you put together, que es minus b, plus or minus square root b squared minus 4ac. And this is a famous quadratic formula que allow us for solving quadratic equation. Quadratic formula. The thing I tried to illustrate was that the quadratic formula comes from for the completed square. Okay, when you complete the square, you prove mathematically, algebraically, the solution, but not necessarily doing that like that. A section que the test asks you to do by completing the square. Oh, I get it now. Okay. Chelsea, Ross. Entonces the example we're doing in Chelsea now is application for this formula directly on the equation, right? Okay, example 1 of the example 1, guys. Example 1. Look. Suppose this equation, x squared plus x plus 5 equals 0. Entonces, no necessary to do using the long way for the complete square. No. You immediately say, this is a quadratic equation? Yes. This equation is expressed in standard form? Yes. Entonces, you immediately determine who is A, B, and C. A is 1, B is 1, C is 5. I'm plugging it into the quadratic formula. Minus 1 plus or minus square root. Oh, no, let me copy the quadratic formula again at the beginning, and now you see the process. Minus b plus or minus square root b squared minus 4ac. I'm using these tools divided by 2a. In our specific example, is minus 1 because b is 1, no? Plus or minus square root 1 squared, que by the way is 1, because 1 times 1 is 1, minus 4 multiplication by 1, que es a, multiplication by 5, que es c, divided by 2 times 1. This is my way, guys. You just replace a, b, and c into the quadratic formula. Don't do any operation because I don't want to confuse me. Now I focus it. In this expression, I apply the order of operations. And the order of operation is this operation first. Operation inside the radical is the high priority. Why? Because it's inside the radical. And the radical working similar to the parentheses. So now, this is 1 squared, que es 1, minus 4 times 1 times 5, 20, is negative 19. Now we compute the square root negative 19, que we studied que is a complex solution, because when you have a square root of the negative number, automatically you see I, imaginary square root 19. And leave it like that because 19 is a prime number. We can no simplification anymore. Now it's negative 1, I copy this negative 1 plus or minus I radical 29 divided by 2, because 2 times 1 is 2. That's it. No. You remember, see, the answer is a complex number. You need to write the complex number in standard. Now you split the common denominator. Negative 1/2 is the real part. Split. Plus or minus I radical 29 divided by 2. Whoa, much better. This solution. In this case, we have two complex solution. And when this situation happens, guys, always the complex solution is coming. We study in detail in the next chapter, but now I anticipate a little bit. Okay, when the solution, when you have two complex solution, the solution complex is coming by a pair of conjugate. So we never have three complex solutions or five. We have two or four, it's an even number. And they are coming by couple of conjugate. Remember, you write solution set separately, not in this notation. Okay, perfect. I prefer this notation. It's easy. It's 1/2 plus I radical 29 over 2, comma, negative 1/2 minus I radical 29 over 2. Boom. Two solution complex and they are conjugate. Another tool to predict that we have complex solution or real solution is in this equation. Let me show you this idea. The expression inside the square root give me the behavior of the solutions, and this is called capital D. Capital D is b squared minus 4ac. This is the discriminant, is the technical name of this. Because discriminates si es real, complex, or whatever, no? Suppose que if the discriminant is a negative number, less than 0, negative number. In this case, the discriminant was negative 19. We expect two complex solution. Si the discriminant is positive, no, we expect two real solution. Maybe rational or irrational. This is not a problem. I cannot detect this. Pero es too complex. And si discriminant is 0, que es very, very, very weird, pero happen, is because this trinomial is perfect square and we have only one real solution. Now, actually it's 2, pero repeated. Okay, repeated. Now this repetition is called multiplicity. Pero no, I don't want to study now. In your moment you study in detail multiplicity. In the chapter 2, not in the chapter 1 case. Everyone follow me so far?
Yes.
Professor, isn't the 29 supposed to be a 19?
But yes, I am crazy. Thank you. It's square root 19, 19, 19, 90. I don't know exactly what my brain visualized 29. So I appreciate some of this. I am human, guy. I am not superhero. So I make a mistake. Every day I make a mistake. Okay. Let's see example 2. So you understand very well this. Let's see example 2. Example 2 is similar. Is x squared plus x plus 1 equal to 0. Okay, again, quadratic equation. Again, repetition. Standard form. I promise I put another example because complicated, weird, no standard, you need to manipulate, pero no, this is the number 1, number 2, que es easy, ¿no? Entonces, identification, standard, A es 1, B es 1, and C es 1. Okay, I apply the formula one more time. I like so much to copy the formula one more time and use substitution. We'll replace the ABC by the corresponding number in our problem. And minus 1 plus or minus square root. Again, 1 squared minus 4, multiplication by 1, multiplication by 1. Divided by 2 times 1. And remember the order of operations. Mandatory using pendas, parentheses, and not exactly parenthesis or bracket. It's, the radical is considered like a grouping symbol and have the same priority. That you should do this operation first. Okay, so it's 1 squared is 1, minus 4 is negative 3. Oh, again, complex. Because the square root of negative 3 is I radical 3. Now we have minus 1 plus or minus I radical 3 divided by 2, okay, you can split. Now the solution is negative 1/2 real part plus or minus I radical 3 over 2. Or if you want to separate, you say, everyone understand in the word. You write separately or together using the symbol plus or minus. It's perfectly understandable. Okay? Clear?
Clear. Yes. Clear. Yes.
Let's move into example 3. You copy, guy? You copy, no?
Yes. Yes.
Yes.
So you copy simultaneously with me, no?
Yes.
Example 3. Example 3 is x squared plus 3x minus 5 equals 0. Okay, this is again quadratic equation. This is expressed in standard, nice, and you identification A, B, C. A is 1, B is 3, and C is negative 5. And this is my formula. Okay, and this is my specific formula for this example. A minus 3 plus or minus the square root 3 squared minus 4 multiplication by 1 multiplication by negative 5. Multiplication divided by 2 times 1. Cool. Be careful now with the signs. It's important. Now I focus in the expression inside. Expression inside. That expression is 3 squared 9 plus double minus. Be careful, 20. 29. And square root 29 is square root 29. Well, you put in a calculator, you get the decimal approximation, but no, I want the exact answer. And 29 is a prime number. We cannot simplification more. Now, so far we have minus 3 plus or minus square root 29 divided by 2. And in this case, no necessary split like that because this is no complex. Complex, yeah, complex you need the specification, real part, imaginary part, but this is not complex. This is real number. Of course, it's weird real number because it's irrational. Square root 29 is irrational, but I'll leave it like that. Okay. So no necessary split these two. No mandatory. Hey, okay. The thing, professor, can do is separate. You can if you want, but not strictly necessary. Solution set is two real solution because the discriminant, when I compute the discriminant, the answer was 29. 29 is positive. So we expect a real solution. Minus 3 plus radical 29 over 2, comma, minus 3 minus radical 29 over 2. Cool, guys? Cool.
Yes.
Okay, I want to put now two weird examples. Okay, we can find the real life. How you handle, how you manipulate. Example 4 and 5. Okay, bring me new situation. For example, in example 4. Example 4 is 18x squared plus 2 equal minus 15x. Solve this equation. Well, I can see clear que es quadratic equation. The clue que give me information que es quadratic equation is this guy. Because exists one term que contains second power. This is quadratic equation. But this equation is not already expressed in standard. Remember, standard is ax squared plus bx plus c equal to 0. So standard needs right-hand side 0. Right-hand side must be 0. Therefore, I move 15 to the other side. And I organize in descending order of the degree. Okay. This is degree 2. This is degree 1. By the way, it's invisible, degree 1. And it's degree 0. Because these two have no x, but in your mind, you suppose x to the 0 power. Because x to the 0 power is 1. It's invisible, no? Now I can see clear like water. A is 18, B is 15, and C is 2. So be careful to solving any quadratic equation. The first thing that you must do, is express in standard. You move everything to the left, right hand side must be 0. Now I am ready to identification ABC. Now I copy my famous quadratic equation, quadratic formula, sorry. Yeah, I replace for the corresponding value of the exercise 2a. Which B? 15. This is minus 15. Remember, the formula bring me one extra negative here. Plus and minus square root 15 squared minus 4 multiplication by 18 gets A, multiplication by 6 gets 2. Don't be scared for the number because we have calculated, no? Okay, but the order of the operation is extremely important. I focus it here. Entonces I put in my calculator. 15 squared is 225. Minus, I put in my calculator. 4 multiplication by 18, multiplication by 2. Oh, either way, 4 times 2 is 8, 8 times 18. Doesn't matter, the order is not important. It's 144. And now subtraction. Oh, nice, it's positive. It's positive now we expect real solution. And also it's good because 81 is perfect square number. So we expect rational, no irrational. It's 9. But so far we have negative 15 plus or minus 9 divided by the multiplication 18 times 2 gets 36. And that's it? No. Now I split this in 2 pieces. One piece using positive and one piece using negative. And you compute separately. Entonces negative 15 plus 9 is negative 6. And now you reduce the lowest term divided by 6 top and bottom is negative 1 over 6. That's my first answer. My second answer is this is negative 24 put together over 36. And when you reduce the lowest term, can you divide it by 12 maybe? It's a common factor, greater common factor is minus 2 terms. Boom. Solution set. 2 solutions. 2 real solutions. Negative 1 over 6, comma, negative 2 terms. Both negative, real. The order that you write is not important. I write this and the piece of paper that I have in front of me, I write different. I put negative 2 terms first and comma negative 1 6 second. Doesn't matter. The order is not important. It's just a set. Any question, guys?
No.
Easy? No. I bring another super important, super interesting. Okay, maybe you can find in the real life. Example 5. Suppose solve this equation. X squared minus 1/3 x minus 2/3 equal to 0. Okay, it's quadratic equation. Yes. How do you know? For this. Is expressed in standard form? Yes. Because the right hand side is 0 and you organize in the left hand side in descending order of the degree. 2, 1, 0. What is the only new thing that brings me this problem? Fractions. And you declare that A is 1, B is negative 1/3, and C is negative 2/3. Yes, you can do that, but it's horrible. It's horrible when you plug in fraction into the quadratic equation. It's maybe confusing. No, you can, but it's confusing. Now, my recommendation is clear the fraction. How you clear the fraction? Well, multiplication by the LCD. If you multiply by the LCD, by the way, 3, the entire equation by 3, everything by 3, you have 3x squared minus 1/3 times 3 is negative 1, so it's 1, but it's negative. And here is 2. And 0 times 3 is 0. And this equation is equivalent 100% to this. So there are no reason to spend time doing the quadratic formula using fraction. No, hello. You eliminate the fraction. Now you declare A is 3, B is negative 1, and C is negative 2. And the rest you know very well. It's doing. Minus B, I like so much to write the equation. Because the repetition, you know by memory the quadratic formula or no? Or not yet?
Yes.
Yeah, you know by memory, right? So it's minus B, but whoa. We have double negative. Negative B is negative 1. However, my formula have a minus. Together is positive. Minus, some students say, no, professor, I prefer put negative, this negative, and you put negative 1. I agree. But I skip this step because I know the double negative is positive. So I put the negative, the positive, sorry, plus and minus square root negative 1 squared minus 4 multiplication by 3 is A, multiplication by negative 2 is C. Divided by 2 times 3. Okay, again, we focus on the expression inside the radical. And the first thing you should do. 1 squared is 1. And this is double negative. Negative 4, negative 2. So it's, 4 multiplication by 3 is 12. Multiplication by 2 is 24, but positive 24. And this is 25. Wow, now compute the square root. You know why you compute the square root? Because the formula have a square root. So you did only mentally, in my mind, I did the operation inside the radical. But this is the moment, this is the time to find the square root of the 5. Okay, by the way, it's positive, it's real, and perfect square. It's 5. Nice. You get nice solution. This is the problem I like so much. So 1 plus or minus 5 divided by 6. Okay, now split. 2 pieces. 1 plus 5 over 6. 1 minus 5 over 6. Plus and minus. This is 6 over 6 is 1. First answer. And this is negative 4 over 6. Okay, we can reduce it in lowest term because 4 and 6 both are even number divided by 2 is negative 2. Boom. Solution set for our problem is 1, comma, or 1, no, it's 1 or negative 1. Well, let me see. No. But I make a mistake, I suppose, no? A ver, what was the mistake? -2. No, it's okay. 1 and -2/3. Because in my paper I copy at the beginning different signs in the equation. Okay. Yeah. See, I make a mistake. I copy different sign in the equation. I'm crazy today. But it's okay. It's okay. Do you follow me, guys? Or no?
Yes. Yes.
Do you remember very well this of the high school, no?
Yes.
Absolutely. It's a classical algebra 1 in high school, no? So now let's move on to the more complicated part. Today is the day of the equation and inequality. Quadratic equation, this is piece of cake for us. But it's the foundation to understand the other equation. We study now radical equation. Radical equation. Radical equation. A radical equation is easy identification because it's an equation que contain radical. So when you see one radical, maybe square root or cubic root or for root either, this is classified like a radical equation. So you need to be careful. Let me explain the theoretical part. Chick. Let me split the board into two pieces. Suppose here we have radical square root. Remember default on the S2 square root, the algebra omit this, and you default suppose this is square root. Suppose here we have square root any expression, any S either. You see example now with me. Equal a number, 10. It's supposed easy to understand. The fantastic key idea to solving any radical equation is, so you have a square root, to say you eliminate the square root using a square, because I know que square root and square powers and second power does each other, and we have any without square root and square, and we have 100 here. Okay, and we continue solving this equation. But what is the problem that you need to be aware? This new equation is not equivalent 100% of the original. No equivalent. But don't worry for this, because in the majority of the scenario, yes, it's equivalent 100%. But there are some scenarios in which no. So how you confirm the solution? Easy. When you find a solution, you need to be aware that some solution maybe is extraneous solutions, and you plug it into the original. That is the reason that when you're solving this, you see now, I never touch the original, waiting for this expecting moment. I never touch the original, because I plug it in. Suppose you have two solutions, solution 1, solution 2, and maybe you plug it in solution 1 here, work, good, and solution 2, no, doesn't work. Oh, there are no rules. You have two solutions and the both solutions are good, work. Oh, this is a weird scenario. The both solution is no good, so we have no solution. This is the idea, right? This is the idea. And what happened? Okay, this is no new. You see it throughout the course. Okay, this situation happened because the radical is picky. Why is picky? Because you know que square root negative number es imaginary. Entonces, an imaginary is out the domain. Entonces, now out the domain is out the solution, out at least the set of the potential solution. Entonces, now you need to verify. Mandatory, guy. Mandatory. I want to see in the test this equation. Always, when I finish, I check it. The checking is most important than the solution. See, it's good. See, work. So I include in the solution set. See, doesn't work now. What's going on in the for example, so you have cubic root of any. And this idea is valid for any even root, maybe square root, 4 root, and so on. But when it's odd, the idea is no like that, it's different. Suppose you have 10 and you apply cubic both sides. Entonces magically happen que it's any because the power and the root index cancel out each other is equal 1000. But the important is in this case we never have extraneous solutions. So you never you get extraneous solution. Extraneous solution is the technical name of the solution that you get here, get solution for this equation, but it's not solution for this equation. But when it's odd, never happens this. Solution that you get here in this equation, 100% working with the original. So you don't need to check it. I bring example that you see, wow, fantastic. So say I ask you, we have a trainer, yes or no? No, yes, no, yes. Depending the index. See, we are working with the cubic root, no. See, we are working with the square root, yes. Or 4 root, yes. Or 5th root, no. Okay? Let's do an example. I bring 1, 2, and 3 examples. A little bit long example. Okay. May I erase the board?
Yes.
Cool. Okay, elementary kindergarten example. Always the first example is elementary. You have one radical. Okay. So for x, don't touch the original. Don't touch. I never touch. I just bring down. Now square is the key idea to open the door for this equation. Then you have 2x minus 1 equal 1. Because 1 square is 1. Okay, so you have the elementary equation, no radical equation anymore. Okay, cool. And now you solve for x. This is a linear equation, easy. 2x equal 1 plus 1. Just 2. Divided by 2. Solve the x is 1. And we finish? No. So you leave it like that and not checking. You have 0 point in the test. Okay? Because you need to know by concept. Okay, the radical equation, you need to check it. Because this, I want to see you split the paper and you put check. 4 x equal 1. I'm plugging in 1 and the original is waiting for this moment. Square root 2 times 1 minus 1 should be 1. And just I put a question mark because I claim this statement. I'm not sure, not always is true. Sometimes it failed. In this case, it's true. Because 2 times 1 is 2. 2 minus 1 is 1. You say radical 1 equals radical 1, of course, true. That means that the solution is good. And the solution set for this equation is just 1. End of story. Do you follow me?
Yes.
Okay. I want to complicate your life. As always, no, I am a complicated guy. At least my wife said I am a complicated guy. But not too much. The thing you need to understand and pass this class. Example 2. This is more interesting. Square root x plus 8 plus 12 outside the radical, of course, equal x. Okay. It's a radical equation. Of course, it's a radical equation. It involves somehow a radical. By the way, square root. So I need to be careful. Because sometimes having a strange solution, maybe. But what is the first thing you should do? Well, the first thing you should do is isolate. You must, mandatory. Isolate the radical. Now the radical must be stay alone. Why? Because the only possibility to destroy the radical is a square. To say I need to remember I don't touch the original. No, never. I move x minus 12. I move 12 to the right hand side like a minus, no? And now it's a moment, crucial moment to square both sides. Okay, I know very well. Take the radical and the square cancel out each other. Now you multiply this. X minus 12 times x minus 12. Some students, we are working here in this class, is for advanced study. Normally in college algebra, for the no advanced studies, regular study, you apply FOIL here. Personally, I don't like, but it's okay. X times x is x squared. X times minus 12 is minus 12x. 12 times x is minus 12x. And negative 12 and negative 12 together, multiplication is positive 144. And when you combine that term, it's x squared minus 24, because negative 12 and negative 12 together, like term, is 24 plus 140. However, the advanced student doing it different. The advanced student know this idea. When you have binomial square, is a squared plus or minus twice ab plus b squared. Let's see, this is easy to prove. Well, doing FOIL in general. Entonces, si I memorize que this is trinomial, and the trinomial, and the first guy is square the first. And who is the first? The first is x. Square is x squared, like that. And the last one is b squared, and b squared 12 squared is 144. In the middle, we have 2 times ab. In our particular example, a is x and b is 12 or negative 12. It doesn't matter. So 12 times 2 is 24, but of course negative 24x. Do you recognize this idea, or you never see before like that? No, you never see. You see. Either way, guys, I am open to any possibility. The thing is that you are doing well. So you prefer FOIL, no problem. See, this is the quick FOIL, in which you memorize que es square of the first, plus or minus, depending on the sign of the binomial, 2 times the multiplication both. In our specific example, 2 times 12 and x is 24, plus square of the second. It's 12 squared is 140. Either way, it's up to you what way you prefer to select. But the student in pre-calculus, and the level of the pre-calculus, doing this way. Okay. So let me copy so far my answer. X plus a in the left, in the right is x squared minus 24x plus 144. It's okay so far?
Yes.
It's okay, yes. Right? Immediately you identify, wow, what the hell? This is quadratic equation. So the equation I have in my moment here is quadratic equation. So I need, remember, to solve in the quadratic equation, putting a standard. You move everything to the left or to the right, depending, no? And normally I explain to the left and right hand side 0, no, but no, because in the right hand side we have 3 guys. In the left hand side you have 2 guys. So I suppose it's more comfortable moving 2 guys to the right, no? And stay 0 here, 0, 0, 0. Remember, the equation is nice. You move in any way. Minus 24x plus 144 minus a x a ver, Yeah. No. Minus ax.
Would it be
Minus a, minus a. I'm crazy. Minus a, minus a, minus x. Or either way. Let's do it in elegant way. Minus x, minus a. Correct? I did well now.
Yes.
Now, x squared, we combine lighter. This and this are lighter because contain the same variable. Entonces negative 25, no? X plus 144 minus a is 136. Wow, and this is my equation. See, I need to feel more comfortable. I switching interchange this equivalent to say x squared minus 25x plus 136 equal to 0. Okay? So it doesn't matter in what side I move, I interchange nice equation que I need to solve y I know how. Entonces yo identify que es cuadratic ABC. A is 1, B is negative 25, and C is 136 positive. I'm plugging it into the quadratic equation. Copy always my quadratic equation. Substitution. Who is B? 25 plus negative. Double negative become positive. Square roots. Negative 25 square plus 4 times A is 1 and B is 136. Divided by 2 times 1. Okay. Guy, I don't know, but I like this organization, no? Because some students try to multiplication and just lost the position. No. You substitution. No, don't do any operation. Now this is a moment to make operation. Okay, I want to erase that part because I need this space. 25 squared is 625. I put in my calculator. Plus 4 times 1 is 4 times 136 is 5, but it's minus. It's minus. See, look, it's minus. This is minus. This is minus. This is minus. Okay, my formula is minus. No negative, entonces stay negative. ¿No? Minus 144. Is the multiplication 4 times 136 because time 1 is the same. Time was invisible. And the answer is subtraction now 81. Ooh, nice. And now square root 81 and 9. And so far we have 25 plus or minus 9 divided by 2. Cool. Separate into pieces. Plus piece, negative piece. We have 25 plus 9 divided by 2 and 25 minus 9 divided by 2. 25 plus 9 is 34 and divided by 2 is 17. I close in the box this 17 because this is maybe potential solution. Remember, potential, I need to prove, I need to check. And 25 minus 9 is 16. 16 divided by 2 is 8. Cool. We need to check in two solutions. In where? In the original equation. So you check in another equation, you are doing wrong. That is the reason I never touch the original, waiting for this moment. And you separate, it's too long, sorry. You check for 17 and you check here for 8. And let's see what happened. I copied the original. Replace x for 17. 17 plus 8 plus 12 outside the radical should be equal to 17. Question marks. I don't know if it's true or false. Square root a plus plus 12 outside should be 8. Let's do it. It's a numerical, it's easy. This is 25. 17 plus 8 is 25. And square root 25 is 5. And 5 plus 12 is 17. Yes. That means 17 is good. Boom. I like this answer. Let's see 8. 8 plus 8, 16. And square root 16 is 4. If 4 plus 12 is 8, no. No, this system is completely false. Now the solution 8 doesn't work. Now the solution set for this equation is the original, is just 17. End the story. The other part is easy. However, the student forgot. So you forgot, you have 0. Okay, 0 point. So you forgot the checking point. Everything is clear?
Clear.
Mm-hmm. Let's do one more radical equation, but this is complicated and long because included 2 radical. Yeah, I need to training to you for this direction. So 2 radicals. So far, the example 1 and example 2 that we are doing so far is solving one radical equation that contain only 1 radical. But suppose that you have 2 radicals. So what should I do? See, we have 2 radicals. Well, you need to eliminate both radicals. And the only possibility to eliminate both radicals is square. Suppose this example. Square root 2x plus 3 minus another square root x plus 1 equal 1. This is the original. I never touch. Okay, so now when you have 2 radicals, you need to eliminate one by one the radical. You cannot, because you suppose you have 2 radicals and you square. It's crazy. No, you need to isolate 1 radical and destroy it like that. And in 1 second stage, you destroy the second radical. This is the good idea. This is a super bad idea. Impossible. Okay? So I may need to make decisions. And decision was, you isolate, for example, the first radical, I copy this. You move the other to the right. And this is the moment to destroy the first radical. But I don't know what happened with the second. The second is not clear for me so far. But okay, no problem. At least you destroy the first radical. And now this is a binomial. You can interpret it like a binomial. Or the student that don't like binomial doing in that way. You follow? 1 times 1 is 1. 1 times a radical is radical. 1 is invisible. In other example, there's no 1, but it's a coefficient, you put it in outside. A radical times 1 is exactly the same. And a radical times a radical is just x plus 1. Do you understand this? So when you have radical any expression, times radical any expression, and this any and this any is the same, the answer is any. It's obvious, right? Without radical. Clear or no?
Clear.
Yes.
Okay. Okay. So now I have a long equation. No good. I try to simplification. How? Combine like term. There are no reason to have this one and this one separately because 1 plus 1 is 2. There are no reason to have this radical and this radical separately because it's twice radical x plus 1. You combine later plus x. Okay, I finish the first part. Like a first stage in which you eliminate at least one. Now, my goal is eliminate the second radical. So I need to do something to eliminate the second radical. Well, to say again, you isolate the second radical. Okay, is 2x plus 3, bring down. I move 2, subtraction. I move x, subtraction, equal to time radical x plus 1. Cool? Now 2x minus x is 1x. And 3 minus 2 is 1. Little by little, you approach it to the solution. Okay, what should I do now? Square. Square is the only possibility. But divided by 2, what happens with the 2? No problem. You square both sides. You square both sides. Now, okay, be careful. Because this is a binomial. This is binomial. And the consideration binomial is x plus 1 times x plus 1. And you multiply like a foil, no? Foil again. Is x squared plus x plus another x plus 1. Remember the shortcut. Square the first plus twice multiplication both equals both x and 1 plus 1 squared. You get the same answer when you combine x plus x is 2x. And the right hand side, no, because you consider like a binomial, well, monomial, because 2 squared is 4, and square root x plus 1 squared is x plus 1. But this is super important detail. See, you write without parentheses, you make a mistake. Because you consider this like a one, guys, and this is another guy. Suppose, hypothetical, AB square. No, AB square es A square, B square. Entonces A es like a 2 square 4, and B square is, you know, square root x plus 1 square, que I know very well, que es x plus 1, because the radical and the power cancel out each other. However, this guy multiplied by 4 entire, right? So this parenthesis is super important, because you made the parenthesis, I suppose, according to the mathematical language, this 4 multiply only x and no 1. Got it? Now you distribute it one more time. It's a 4x plus 4. I know, guys, get too long. Sorry, it's not my fault. And now you have quadratic equation, but it's not already expressed in standard. Entonces, x squared plus 2x plus 1 minus 4x minus 4 equal to 0. Now ready to combine. X squared, 2x minus 4 is minus 2. And 1 minus 4 is minus 3 equals 0. I suppose you remember, not all quadratic equation you need to apply quadratic formula. Quadratic formula is fantastic. What is the only disadvantage? Que quadratic formula is too long. Entonces, no, there are shortcuts to do fast doing factorization. Entonces, my recommendation is you apply factorization. You see the equation. You spend only 2 seconds to see if you see or no the combination of the factorization. See you see, nice. See you don't see, no. Because you forgot factorization, apply the quadratic formula. But in this case, it's obvious that the combination, well, this is x2 binomial, is 3 and 1. No? It's 3 and 1 because 3 times 1 is 3, and somehow 3 minus 1 is 2. And you adjust the sign. The sign is obvious as minus and plus. Do you have any question for the factorization or no? No. This is easy. And you separate the equation in two linear equations. Easy, pretty easy. You solve it separately. The first answer is 3. And the second answer is -1. In this moment, guys, some students are tired and finish. Okay, too much. Finish. And this is wrong or right? I need to do some extra or no?
Yes, we have to check.
Exactly. She said you need to check it. Check it for both. You split the paper and you checking the equation at 3 and you checking the equation at -1. But the professor says something, a negative is not good, guy. It's not really true 100%. Depending you don't know. The mathematics is fantastic, and you check it. So you take what equation I need to check it, and in which one, because I have a lot of equations here. In what equation? And the original. Okay, never using waiting for this. Okay, super. So now you're right. Square root 2 times 3 plus 3 minus square root 3 plus 1 should be 1. I claim that. Likewise, square root 2 times -1 plus 3 minus square root -1 plus 1 should be 1. Wow, I don't know. 2 times 2 is 6. This is 6, and 6 plus 3 is 9. And the square root of 9 is 3. Minus 3 plus 1 is 4. And the square root of 4 is 2. And 3 minus 2 is 1. Super. The solution is good. Right, let's see a second. 2 times -1 is -2. And -2 plus 3 is +1. And square root of +1 is 1. And -1 plus 1 is 0. And the square root of 0 is 0. And 1 minus 0 is 1. It's also okay. Both solutions are okay. Satisfy perfectly my equation. Therefore, the solution set is 3 and -1. Or -1 times or -1,3. Doesn't matter, the order is not important. The order is not important. I promise the applications you can see radical equation, and you need to be aware how we solving this, and when you're checking and we don't need to check. So far it's okay?
Yep, good.
Let's move on to another topic. Okay, it's a continuation. It's not completely different. It's a polynomial equation. Polynomial equations. And I want to emphasize one specific is quadratic. Quadratic in form. this is the most important. So we study polynomial equation. Nice. But one particular is quadratic form. Que sound like a quadratic equation, but no. Actually, it's different. No different. It's similar, but it's just polynomial. So quadratic equation, quadratic from equation, maybe it's polynomial, but a special polynomial. Okay, so let me definition. What is polynomial? What is polynomial? Well, the polynomial is the collection of monomial. And the monomial, all we have, whole number coefficients. Whole number coefficients. What is whole number coefficients? 0, 1, 2, 3, 4, 5. No negative. So, okay. When you see an equation that contains, for example, fraction exponent, like that. No, it's not polynomial. When you see an equation that contains negative exponent, you see now, but in another way, x to the minus 2 plus x to the minus 1 plus at least one time. Suppose that another exponent is positive. Nice. But at least one exponent is not polynomial. So the definition of the polynomial equation is this equation that contains a variable, one variable, single variable, but the exponents are whole numbers. Whole numbers. Entonces, the beauty que happen when you have polynomial is que si the degree of the polynomial is 3, for example, that by the way, degree is the higher exponent in the equation, you have 3 solutions. Okay, see the degree is 4 solutions and so on. But always this happens in the polynomial equation. Another equation that contains fraction. Another equation that contains negative non-polynomial. Entonces this idea is totally invalid. By the way, this is the fundamental theorem of algebra. The fundamental theorem of algebra say, I want to explain in the chapter 2 in detail. When you have a polynomial equations, okay, now the solutions of this polynomial equation is exactly the same number of the degree, include a repetition and include a complex. And remember, the complex is coming by couple of conjugate. But it's okay. It's a chapter 2. In chapter 1, the only thing you need to remember is recognize example 1. Okay, this equation that right now is polynomial. Okay, x cubed minus x squared minus 2x equals 0. Okay, nice. Polynomial. By the way, what is the degree of this equation?
3.
3. Because when I finish that problem, we expect 3 solutions. Okay? And so far, the only technique that we apply in the chapter 1 is factorization. The problem in the chapter 2, we apply another sophisticated technique. And inside the factorization, remember, we have different categories. We have GCF. We have grouping. We have trinomial factorization. Binomial factorization. We have grouping. Okay, grouping is when you have 4 guys. Grouping, factorization by grouping. In this case, no. In this case only, you apply factorization, GCF, because I see x is common factor. What is the greater common factor in this in the left-hand side of this equation? Well, x, you factor out x. You have x squared minus x minus 2 equal to 0, right? And this is, we factor completely this? No, because I see one trinomial. So maybe it's possible factorization of this trinomial into binomial. I put a variable that is x, And the combination, of course, is 2 and 1, because 2 times 1 is 2, and 2 minus 1 is 1, like that. And what about the sign, negative and positive? When you factor completed, this left-hand side and the right-hand side is 0, it's important. You separate each factor by a linear equation. Apply zero factor rule. Zero factor rule. What say zero factor rule? See, each factor is equal to 0 is because the first factor is 0 or the second factor is 0 or the third factor is 0 or together is 0. Entonces you separate the problem into linear equation elementary. The first one is 0, the second is 2, and the third is negative. And the solution set for this polynomial equation is 0, 2, and 1, and negative 1. In the story. Important. 3 important polynomial equations. And we come back again in the chapter 2 in detail. More strong, because so far it's weak. The analysis no, depending the factorization, and the factorization is a little bit weak in my opinion. Not always we can do that. Example 2. Let me try. X cubed minus 3x squared minus 4x plus 12 equal to 0. My question is, a polynomial equation, yes or no? Poly, yes or no? Help me. This equation is polynomial equation or no?
Yes.
Yeah, how do you know, miss?
There's no fraction or negatives and the exponents.
Negative. So in other words, whole numbers. Just equivalent to say no fraction. Super. What is the degree of this equation?
3.
3. How many solutions we expect when they finish?
3.
In this case, it's obvious that you apply factorization by grouping, because we have 1, 2, 3, 4. It's a clue that give me information. When you have 4 terms in the equation, you apply factorization by grouping. You grouping. I don't know see this combination is good or not. I try, see it doesn't work, but I try another combination, no? But what is the idea? Say again.
My Wi-Fi was lagging when you were explaining the degree. Can you help me determine?
Okay. Degree is the higher exponent in the equation. Do you see this number, right? Yes or no?
Yes.
So my polynomial equation contains degree 3. And we know by memory one theorem que say que in one polynomial equation, the amount of solution that we have is exactly the same number of the degree. O sea, the amount of solution is coincident with the degree of the equation. Cool?
Okay. Yeah.
Now, this is conceptual. This is totally theoretical. Now the practical idea. The practical idea was the practical idea is I can see the only tool that the professor explained is factorization. So far. Entonces I remember very well that when you have 4 guys, polynomial 4 is by grouping. Factorization by grouping. Now by grouping who? Well, by grouping, I don't know. I suppose the first and the second and the third and the last. I don't know if it works, doesn't work. Let me try, at least try. The greatest common factor, and the first combo is obvious is x squared. Now we have x minus 3. And the great common factor in the second couple, que is the blue couple, I suppose get 4, right? But I don't know very well if it's positive 4 or negative 4. But at least let me try. I factor out negative 4, and when you put a parenthesis inside, you have x minus 3. Make sense or no? You want double checking. Yeah. You double checking, you multiply negative 4 times x is negative 4x, and negative 4 times negative 3 is a positive x. Super good. And in this moment, I realize that I'm doing well because this guy is the same. When this guy is the same, I am so happy. Look at my face. Happy face. Because the selection that I did in the couple, the red one and the blue one, was correct. Maybe sometimes happen that you select, no, you don't get the same binomial. Entonces I'm sad. I change my face. And I need to select in another order. Okay, maybe the second and the third, but in this case, no. This case worked perfectly. Now factorization again, the factor by grouping is factorization one more time, que es x minus 3, I detecting que es the common factor again, and we have x squared minus 4, no? Equals 0. So this guy, I copy it one time, I factor out, and this x squared is this, and this negative 4 is this, right? Do you see? No, I erased my face. Now I finish. No, because I can see I'm detecting differences of a square. The technique of binomial. Differences of a square. Let me recall the formula. A squared minus b squared is equal to factorization a plus b, a minus b. It's a famous formula that you know very well, right? So I'm detecting that this is the difference of a square. And the factorization, this is not completed the factorization, we need to continue. X minus 3, and you break it down in two parentheses. This is x, que es square root x squared, and the square root for 2, and plus and minus. Now the factorization in the left hand side now is already completed. Now, yeah, you know, don't need to write anything. X equal 3. It's completely opposite sign. See, in the factorization you see negative, and in the solution you see positive. This is negative 2, and this is positive. Now, solution set for this polynomial equation is 3, negative 2, positive. End the story. What do you think about polynomial equation? Is easy or no?
It's easy.
Yes.
No, but I want to complicate life. I want to complicate. Yeah. Dulce Mejia. He says easy. I want to complicate. Look, because sometimes happens that we have complex. Remember, degree 3 solutions, but maybe this 3 solution is real or complex or repeated multiplicity. Let's see example 3. Now you help me a little bit. This is look like easy, however, no, it's not easy. Okay, question number 1. A polynomial, yes or no?
Yes.
Yes. Question number 2. What is the degree?
3.
How many? 3 solutions. 3 solutions considered real, complex, and repeated. Suppose. No. This is stupid solution. 1, 1, 2. How many solutions we have here? 3 solutions, right? So you consider the theorem say the degree is 3, and we expect 3 solutions considered complex, repeated. You count everything, but it's 3. Okay, and the repeated, no, it's coming by couple. No, it's 2 or 4 or 6. Okay, so now let's do a factorization. Okay, But in this case, the factorization is a little bit weird. Because it's binomial, no? Pero you need to remember difference of cubic. See, you don't remember, I refresh your memory. Don't worry. When you have that binomial, the factorization is a minus b, a squared plus ab plus b squared. This is the formula. You remember high school this formula? Oh no.
Yes.
I make a mistake. It's minus here. A ver, es minus o es plus. No, es plus, es plus. Es plus. Es igual. Ajá, entonces, bueno, the question que fly in the air is, bueno, professor, I don't understand. What is the reason que you don't factorization this trinomial? You don't continue into binomial. The reason is clear. Because in this scenario, this trinomial is impossible factorization. It's prime. And when this situation happens, it's because the solution of this trinomial is complex. So the expectation in this problem is that we have one real solution that's not part and two complex. Okay, by the way, they are conjugate. But don't worry too much. Let's do it. Let's apply the formula. The formula is you replace this by one binomial and one trinomial. And inside we apply the cubic root of x cubic is x. And you apply the cubic root of 8, get 2. And between both minus, look, this part is the formula. And the second part is a little bit more complicated because this is x, this is 2, this is like a, this is b, but this is x squared because this is square this guy, plus multiplication both 2x, a and b, plus the square the second que 4. Do you follow me? We are lost. Do you understand where I come from, this 4 and this 2?
Yes.
Okay. Okay, cool. Now, let me erase that part. I separate. This is x minus 2 equals 0. And this is x squared plus 2x plus 4 equals 0. This is piece okay. This is 2. One real solution. One real solution. However, the professor say that this is complex, but I have no idea. Let me try. I try to do my best. In this equation, I can see clear that A is 1, B is 2, and C is 4. And this is my quadratic formula because by factorization it's impossible doing that. The complex never we get by factorization. Well, no. Let's see in the chapter 4. The chapter 2, sorry. Entonces minus 2 plus and minus square root something. Square root something. B. Who is B? B is 2 squared. Minus 4 multiplication by 1 multiplication by 4. Divided by 2 times 1. I focus it in the expression inside here. It's okay. It's 4. This is 4. 2 squared 4. Minus 16, no? It's 12, no? Minus 12. Oh, you see what the reason is complex because the square root negative 12 is I. The square root positive 12. And positive 12, we can simplification a little bit because I know that 12 is 4 and 3. and the square root 4 is 2, and the square root 3 no. So this is equivalent to say 2i radical 3. It's much better, more elegant, no? No, when when you have a number inside the radical, you need to break it down and analyze. See, we have a couple or no, the factor that we can simplification and put outside the radical. And so far we have minus 2 plus or minus 2i radical 3 divided by 2. Oh, so we having when you have complex solution. Well, I expressing a standard, I need mandatory to split this common denominator. So it's minus 2 over 2 plus or minus I 2 radical 3 over 2. Es obvio que es negative 1 plus or minus I radical 3. Wow, entonces how many solutions in total we have? Well, we have one real and two complex. And this complex is coming by a couple of conjugates. You want to write in detail solution set. Okay, this is not mandatory. So you leave it like that, you have 100 points. This and this, end the story. But I am a teacher, you say I want to emphasize okay, this is 2 gets real, guys, and 2 imaginary gets negative 1 plus I radical 3, comma, negative 1 minus I radical 3. Boom, 3 solutions. 1, 2, and 3. Degree 3, polynomial equation. Clear or confused?
Clear.
Okay, I have another example, very interesting. And also 2 more of the quadratic form I never explained now so far. Example 4, polynomial so far. Polynomial. Example 4. X to the 4th power minus 16 equal to 0. Degree 4. When you finish, you expect 4 solutions. Factorization. I can see difference of a square. Same formula. Okay, the formula is a squared minus b squared is equal a plus b, a minus b. Bueno, pero professor, this formula is applied when it's 2, but not when it's 4. It's applied when it's even in general. Under the consideration, the 4 is square, double square, no? Entonces you break it down into parentheses. Square root of this guy is x squared, and 4 is 4, and minus and plus. I leave it like that? No, because we can apply one more time this formula. Only when it's positive, no! When it's positive prime expression, this is prime expression. I need to remember that the sum of square is prime. And what is the reason it's prime? And the reason it's prime is because the solution is complex. And you see in a few minutes, it's complex. Okay. So now I finish the factorization? No. I decompose. This is like x to do this part because it's minus, it's plus no. It's a plus or minus, and this stays the same. Sometimes that part is called irreducible quadratic expression. But it's a name, just a name. Okay, now ready to apply the rule of the 0 factor rule. The first is x plus 2 equals 0. Nice, it's real. By the way, it's negative 2. X minus 2 is equal to 0. The solution is positive. And the second is x squared plus 4 equal to 0. Wow, it's a quadratic equation. So I found inside the polynomial equation, degree 4, one quadratic equation. Now, it's easy, you're solving. You isolate the x squared because it's a square root method, so b is 0. Is equal to -4, apply square root both sides. X is equal plus or minus, don't forget plus or minus, and square root 4 is 2. Pero 2. Wow. So now how many solutions? Well, solution set, we have 2 real, minus 2 and 2 positive. And we have 2 imaginary, okay? The imaginary or complex is coming by couple of conjugate. Okay, it's 2i positive and minus 2. Boom. Final answer. Okay. Okay, entonces es easy identification of the polynomial equation because the exponent is a whole numbers. And immediately, it's very important the classification because you apply the fundamental theorem of algebra. See the degree of 4. When they finish, we expect 4 solutions. See, you are doing not good. Some student skip this step. Look what this is the mistake. No mistake, but it's totally incomplete. Suppose this equation: x to the 4th power minus 16 equals 0. You solve it like a linear equation. And you apply 4 root. X equal and 4 root 16 is 2. And bueno, okay. Entonces now professors explain me when it's even root, you put plus or minus. Okay, you have this solution and this solution, and you lost the complex solution. Okay. Everything is okay so far?
Yes.
I want to explain now another kind of equation that's super important. I explain now, but the last day in the chapter 3, we continue working with this equation. This is quadratic form. And quadratic form is special. It's special why? Because we can transform it in quadratic equation. So you have horrible equation, horrible, terrible. Polynomial, no polynomial. Let's see one example que es polynomial, but it's also quadratic form. Another que es no polynomial, pero es quadratic form. O sea, no necessarily polynomial means que es quadratic form. What is the idea behind quadratic form? Es que you have two exponents, and the bigger exponent is 2y, the smaller exponent. Okay. Let me explain example 1, que is super easy to understand. And after we can generalize. 3x to the 4th power minus 2x squared minus 1 equal to 0. Okay, question number 1. ¿Es polinomio, yes or no?
Yes.
Si es poly, degree 3, no? Degree 4, sorry. We have 4 solutions, right?
Yes.
But it's beyond polynomial. It's quadratic form. How do you know? Because the bigger exponent is twice the smaller exponent. So we can do one fantastic thing I want to explain now, and you magically, this is science fiction. You convert this equation to quadratic equation. That is the reason it's called quadratic form. Now the magic thing is not too difficult to understand. You are doing substitution. You change variable. You change the original variable for another variable. Okay, normally I don't know why it's called u. U is the new variable that we use it always in mathematics. You change the variable u by x squared. So you take the smaller exponent, you have 4 and 2, you realize que es quadratic form, and you apply substitution, que es, you define u, que es a new auxiliary variable, que is my friend, que help me to convert this quadratic horrible equation or polynomial equation to quadratic equation. How you apply that? I bring down 0, I bring down -1, but this is minus 2u because I define que u is x squared. And this is 3u to the second power, correct? Because x to the 4 is equivalent to, say, x to the second to the second. But you know that u is x to the second, so u squared, right?
Right.
This is not always possible to do that. But in some scenario, que you detecting que my equation is quadratic from happy. Because I apply the substitution, I convert to quadratic, and the rest of the story you know very well. Or I suppose that you know very well. Okay, this new equation actually is quadratic equation, in which A is 3, B is -2, and C is -1. And you apply the famous quadratic equation, quadratic formula, sorry. Is 2, because we have double minus, no? minus together, plus and minus, square root, -2 squared, -4 times 3 times -1, divided by 2 times 3. Math, remember, math is slow down. You need time to, so you are doing, too fast, you make a mistake. I make a mistake. When I feel pressure, the student pressure me, just I make a mistake because I lost concentration. So now, a -2 squared 4. Nice. And double negative, negative together, plus 12, no? And this 16, oh, nice. I appreciate so much. 16 is perfect square number, effort. So far, we have 2 plus and minus 4 divided by 6. 2 times 3 is 6. Split into pieces. The piece can using positive sign, and the piece can use a negative sign. This is 6 over 6 is 1. Wow. Nice. I like that. And the other guy is -2 over 6. Okay, -1. And this is the answer of the equation. No. This is the confusing part. Remember. We have the original ugly equation. And this original ugly equation, we convert using the substitution and u. Now the new equation, que es my auxiliary equation, give me two solutions, that's 1 and -1/3. But this is not the value of the x, que es my original variable. This is the value of the u. Pero almost I finish because I come back to the substitution. Look. Yeah, I replace u by the corresponding value. X squared equal 1. Let me split the paper in two parts. And x squared equal -1/3. Okay. So in this moment, I have two equations separately, but it's quadratic equation. When I solve this quadratic equation, I suppose that you get two solutions. When you solve the second, you have two solutions, and 2 plus 2 is 4 is exactly the degree of the original equation. Okay? But this is super elementary, straightforward, because it's incomplete quadratic equation. You apply directly the square root method. So x is equal plus or minus 1. I have two solutions, two real. Here we have x equal, oh, it's not real, it's imaginary because it's negative inside the radical. It's I square root 1/3. And leave it like that. No, I don't like this. This is correct. You leave it like that, 100 points, but it's aesthetically not good. This is I square root 1 over square root 3. Square root 1 is 1. And the square root 3 is a square root 3 because 3 is a prime number. This answer is equivalent to this, but this is not aesthetically good. And you rationalize, I suppose you remember very well rationalize, just eliminate the radical, the denominator, and this is radical 3 because 1 times radical 3 is 3, and radical 3 times radical 3 is 2. Wow. And we have two imaginary solutions. So what is my solution set of the original equation? No, it's polynomial, but it's also quadratic form. I apply the technique of the quadratic form. Here I get two real solutions, that's 1 and -1, and two pure imaginary, is I radical 3 over 3 positive. I forgot the most important part, plus and minus. Hello, I am crazy. Plus and minus, so say one positive and one negative. Remember, guys, always when you apply a square root method, don't forget plus and minus. I don't forget here, but I forgot here. Okay, summarize, condensing. We have polynomial equation, degree 4, but it's also quadratic form. Therefore, I convert using the substitution like a quadratic. I solve it by the traditional quadratic, but the value that you get is the value of the new auxiliary variable, u. Now I'm going to recover the original variable x, use substitution, each value into the substitution. Okay, what is the substitution expression? That one. Okay, and you convert the problem now into a quadratic equation, and that's it. Let me complicate your life now. And you help me to understand this. Example 2. Suppose 5 x to the -2 minus 14 x to the -1 minus 3 equal to 0. Solve this equation. This equation is polynomial, yes or no? Poly. ¿Es poly?
No.
No poly. No poly. Entonces, now, si es no poly, this is important, the classification, because it's no poly, it doesn't have no sense to talking about degree. No, degree -2 it's impossible. Then, the amount of solution not necessarily is, I don't know si es 2, si es 3, si es 4, I don't know. No rule, no theorem can cover this idea because it's no poly. Poly is special, guys. Ahora, my second question is, this equation is quadratic in form. Yes or no? And the only requirement for the quadratic form is that you have two exponents. And the relationship between the exponent is that the big exponent or whatever is twice. So this exponent and this exponent. And this exponent is twice or no?
It's a quadratic, yeah.
Yes, like she said, definitely. This is a quadratic. And the quadratic in front equation is the equation the student remember very well because it's the equation, professor, that you solve using U substitution. And the U substitution is always the exponent in which the actual value is smaller. So in between -2, I know that -2 is less than -1, but I focus it in the actual value. So it's -1. Okay, by the way, you know, when the exponent is negative, it's reciprocal. Either way, because you can write the equation that some students prefer doing the equation in that way. It's equivalent, no? Personally, no, I don't like this. I like the original because I am ready to rewrite the new equation using U substitution. Remember, I start for the equal sign because the equal sign split the equation in two parts, left and right. Right is always 0 because it's a standard. 3 is 3. 14 is 14u, because according to my definition, x to the negative 1 power is u, and this is u squared. Wow, and this new equation actually is quadratic equation that you solving by the traditional way you are doing all the time. A, B, C. A is 5, B is negative 14, and C is negative 3. And you apply one more time our famous important formula, quadratic formula for solving any quadratic. And the transformation was by detecting that this equation is no polynomial, but is quadratic form. So I can transform it by quadratic using the substitution U. Okay, entonces 14, ¿no? 14, pero okay, wait. I need to be clear with the signs. Negative and negative. Oh yeah, positive. Cool. Plus or minus. Square root. Negative 14 square. Minus 4 multiplication by 5 is A, multiplication by negative 3 is C. Divided by 2, 8. Oh, I forgot this A, it's important. 2 times 5. So now I focus to remember and the expression. You say something in the chat? Open the microphone. Don't hesitate. I have to go my next class. Okay, no problem. Right. Technically, the class is over, no? We finished 120, no? I always take it. Do you let me know, finish this problem and that's it? You can see, you can leave because you have another class, no? But no, okay. This is the 196 plus double minus 60. The answer is 256. And the square root 256 is 16. You have 14 plus or minus 16 divided by 10. 2 times 5 is 10. So we have you separate into pieces. 14 plus 16 over 10. And 14 minus 16 over 10. This is 30 over 10 is 3. Boom. And this is negative something, negative 2 over 10 can reduce and lowest term in negative 1/5. And this is the solution? No. Why no? Because it's the u value. I need to find x value. But what is the relationship connecting u and x? Reciprocal. Look at that. Negative exponent, negative 1 exponent. So flip it. It's super easy. X is equal, you take 3, 1/3. And x equal, flip it that, negative 5. End the story. Flip it because in this case, just reciprocal. Don't necessary to write any equation. It's using common sense and logical. Is this. Solution set is 1/3, comma negative 5, or negative 5, comma 1/3. Good afternoon, everyone. I am leaving. I have another class after that. Thank you so much for your attention. Remember, working in the Alex guy as soon as possible.